In this video, I'm going to explain about the source-based RTBH or source-based remotely triggered black hole. As you remember, in previous video, we learned about the destination-based RTBH. For example, in this scenario, we learn how we can drop the traffic received from the attackers. In previous scenario, the R6 and R7, both of them were attackers. And as you remember, we dropped those traffic. But here, as you can see, we have a good customer and also one attacker. What does it mean? It means that we don't want to drop all traffic to the destination of, for example, this server. And with destination-based RTBH, you look only at the destination IP of the packet and then drop it. But here, if you want to use destination-based RTBH, the traffic of good customer also will remove. And it is not actually a good choice to drop the traffic received from all customers. We want to drop the traffic received only from an attacker. How we can implement this feature? It is very easy. Actually, we can say if you want to implement source-based RTBH, you need to add one extra feature, uRPF lose mode. As you can see here, we have unicast reverse pass forwarding or uRPF lose mode. If you remember from your previous learning, you know that in uRPF, especially loose mode, when you receive a packet in one interface, you expect to have the source IP of that packet inside the routing table. If it is available, the traffic will be accepted and forwarded according to the destination IP. Don't forget, I'm talking about the loose mode, not a strict mode. For example, here, in the top scenario, we have a packet with the source IP of 10.0.99.3, and also inside the routing table, we have this entry. Because of that, this packet will accept it and also forwarded according to the destination IP. But in the bottom scenario, as you can see, the source IP is 10.0.84.17, and this IP address is not available in the networks of routing table. Because of that, the traffic will be discarded. This is a feature, we call it uRPF lose mode or loose mode. Actually, here we have a little difference between the uRPF loose mode and strict mode. I'm not going to explain about uRPF itself, but we use uRPF loose mode with the RTBH to create source-based RTBH. Actually, we can say source-based RTBH is extra feature over the destination-based RTBH. But how it works? Let me to review the configuration we learned about the destination-based RTBH. You know that in destination-based RTBH, we created a black hole route in the edge routers and also in the trigger router. For example, here we configured 192.0.2.1/32 with outgoing interface null 0. You know that this is the black hole route. Okay, we have this route in the router 2 and also in the router 4 and also in the trigger router R5. Okay, and then when we received a traffic, for example, to destination of 100.0.0.10, okay, and that traffic was received from one or multiple attacker, we sent, okay, BGP update or trigger actually update from the trigger router to the router 2 and router 4. And in this BGP update, okay, if you remember we sent 100.0.0.10/32 with the next top attribute of 192.0.2.1, okay, and some other attributes like the community, like the actually origin. And then the router 2 and router 4, okay, will use this actually information and add this entry in the routing table 100.0.0.10/32, and the next stop is 192.0.2.1. What does it mean? It means that if we receive a traffic for this destination, we should forward it to the 192.0.2.1, and it means that we should drop it. We learned about it, but now I'm going to change a little this approach, because I don't want to drop all traffic received for this IP address. Here, in the source-based RTBH, okay, actually, in the router 2 and router 4, means in the edge router, we enable uRPF loose mode. Okay, for example, here on this interface, we enable uRPF loose mode with one specific command. It's very easy. And after this configuration, okay, instead of sending the iBGP update or trigger update from the trigger router to the IP address of the server, for the IP address of the server, we use this actually IP address as the IP address of, or so as the IP address equal to the source IP of the packets we receive from the attacker. For example, if we receive the attacker packets with the source IP of router 7, for example 10.4.7.7, okay, and destination is 100.0.0.10. This is from the attacker, and this is from the good customer. The source IP is 10.2.6.6. Okay, we don't want to drop the traffic of good customer. We want to drop traffic of only attacker. Here, you send iBGP update, okay, and the NLRI of this iBGP update refer to the 10.4.7.7/32, okay, and then, and also here 10.4.7.7/32 with the next stop, for example 192.0.2.1. This is the black hole route. After receiving this entry, okay, in router 2 and router 4, we will have this entry. Look at here, the 10.4.7.7/32. The next stop is 192.0.2.1. okay, and also in the router 2, we will have the same entry, 10.4.7.7/32. The actually next stop is 192.0.2.1. Okay, now what is happening? First, let me to inform you about the rule of loose uRPF. Loose uRPF checks the packet and forwards it if there is a route entry for the source IP of the incoming packet in the router routing table or FIB. If the router does not have a routing table entry or FIB entry for the source IP address, or if the entry points to null 0, okay, the reverse pass forwarding or uRPF check fails and the packet is dropped. It means that when we receive a packet with the source IP of 10.4.7.7, this source IP is available inside the routing table, but its next hop is 192.0.2.1 and it should forward to the null 0. It means that it should be dropped. Now uRPF check the source IP, compare it with the routing table, and it will drop it. But the source IP 10.2.6.6 is available inside the routing table of router 2 because we have connectivity to this IP address with some methods. For example, in router 6 we configured redistribute or connected in BGP or some other methods. I will show you. Because of that, the router 6 traffic can reach to the server and router 7 traffic will be dropped. This is the source-based actually RTBH. Let me configure this scenario and then you can easily and better understand the actually source-based RTBH. About the configuration, everything is similar to the destination-based RTBH, like the configuration of the discard route in the router 2, in the router 4 and router 5, and also configuration of route map and also the redistributing static routes. The only thing that is changed is the configuration of a static route entering the trigger router, or actually victim route, that we configure the static route to the IP address for the IP address of the attacker, not the IP address of the server. Let me to show you how we configure source-based RTBH. Alright, this is our scenario for source-based BGP RTBH. As you can see, we have a good customer and also an attacker. Both of them now have reachability to the server. Let me to show you. I configured the service provider like the previous scenario. We have iBGP full mesh between the router 1, router 2, router 3, and router 4. And also we have iBGP neighborship between the router 5, means trigger router, and router 2, and also between the router 5 and router 4. Between the router 2 and router 6, we have eBGP, and between the router 4 and router 7 also we have eBGP neighborship. Let me to first show you that we have connectivity from the router 6 and router 7 to the server. With the ping command, ping 100.0.0.10, we have connectivity, and also router 7 ping 100.0.0.10. We have connectivity. Then in router 2 and router 3, you know that first we need to configure the black hole route, and also in router 5. Actually, in the text file, if you check the first step, step 1, you will see in step 1 we need to check connectivity between the R6 and R7 and also the server. In step 2, that is our first step for configuration of RTBH, actually, or source-based RTBH, we need to configure the null route or black hole route in the router 2, router 4, and router 5, exactly same as destination-based RTBH. Okay, because of that, let me to configure it here. In router 2, IP route 192.0.2.1 quad 255, and the actually outgoing interface is the null 0. Do show IP route static can show us that we have this entry in our routing table. Also in the router 4, again IP route, then 192.0.2.1 quad 255, and after that the outgoing interface is null 0. Do show IP route static can show us that we have this entry in our routing table. And finally in the trigger router R5, again IP route 192.0.2.1 quad 255, and after that null 0. That's it. Do show IP route, and after that static. Yes, we have this entry in our routing table. This is the first step of configuration. Then we need to configure the route map. This route map will be used to injecting the routes, static route that we configure in the trigger router into the BGP table and then routing table. Actually, you know that this is exactly same as the route map we configured for destination-based RTBH. Because of that, here in the router 5, I'm going to configure this route map. First, let me to show you, do show route map. We don't have any route map. And then route map, for example, RTBH, okay. And after that, permit 10. First, match tag 100. We use this tag for selecting the static routes that are desired. And after that, the next entry, set IP next hop to the 192.0.2.1, and then set origin to the IGP, and then set community, okay, set community to the no export. I explained all of these features in the previous video about the destination-based RTBH. That's it. This is the next step. And also after that, again, like the previous scenario, we configure the actually BGP for redistributing static routes into the route BGP table according to the roadmap we configured here. Here in the router 5, router BGP 65,000, and after that we configure the redistribute static and then route map RTBH. Until now we configured destination-based RTBH. Okay, actually the source-based RTBH is an extra feature over the destination-based RTBH. You know that if you configure a static route, okay, it will redistribute it to the, with the actually with tag 100, it will be redistributed to the BGP, and then will be sent from router 5 to router 2 and router 4 as a trigger. But how we enable uRPF to check the source IP? You need to go to the edge routers, means router 2 and router 4, okay, and configure the gigabit 02 as the customer facing interface for this feature. Interface gigabit 02. The command is exactly the same as the previously learned actually uRPF loose mode configuration. The command is IP verify source reachable, okay, IP verify source, okay, and then you need to configure IP verify unicast source, IP verify unicast, and then source, and then reachable via the any. Here, this command is for uRPF loose mode, okay. You can change it a little for uRPF restrict mode or strict mode actually. Okay, this is the R2's configuration for gigabit 02, and also in router 4 again, interface gigabit 02, IP verify unicast source reachable via any. That's it. And now everything is ready for sending our static route. Remember that in router 5 we configure a static route, not for the actually IP address of the server. You can configure it here, it is possible, but we don't want to work according to the destination IP. We want to watch to the source IP, okay? But if you want, you can configure destination IP here. Actually, it means that if you configure source-based RTBH, actually you configured both of source-based RTBH and destination-based RTBH. Because of that, in router 5, now we configure this command, IP route. The source IP of the packet that we want to drop is 10.4.7.7. Look at here, in R6, now we have connectivity, repeat 1 million without any problem. And also in R7, ping, for example, 10 or 100.0.0.10, repeat, again 1 million. Both of them can send traffic to the server. Now, in router 5, I configure this command, IP route. Here, I don't configure the IP address of the server. I configure the source IP of the packet from the attacker, means 10.4.7.7, QA 255. Okay, and then match here null 0, and after that, the tag, for example, 100. And after that, you know that this entry will be redistributed to BGP and injected to the BGP table. And after changing the next hop to the 192.0.2.1 and setting the community and also origin, will be sent to the router 2 and router 4. And because here we have the uRPF loose mode, the R4 will find that this IP, the source IP of the packet received from on the gigabit 02 that is enabled for uRPF is pointing to the null 0. Because of that, it will drop it. Look at here. In router 6, we don't have any problem. In router 7, as you can see, traffic is dropping. It's very interesting. And I think it is more usable than actually destination-based BGP RTBH. And also, I'm actually going to emphasize that while we have achieved source-based black holing with uRPF, destination-based black holing is also in effect because of the null route. Any packet entering an edge interface will be dropped if it has a black hole IP as either its source or destination address.